Okay, so we will proceed on Cull face. So, what is kind of uh, why we need kind of culling a face? Okay, so this is Linux Mint. Okay, reversing and culling polygon faces. So polygon, I believe it's quite easy to understand. So basic thing that we draw, it's called primitive, and in OpenGL, like triangle, quad. So these are polygons. Okay, so we'll see what is polygon faces, front and back, and then what is culling polygon faces and reversing the polygon faces clockwise and counterclockwise. Okay, so before we proceed, little bit we'll talk about the OpenGL pipelining. So this is a surface. It has three vertices V1, V2 and V3. So there are three vertices, and if there are three vertices, then certainly there is a surface. So surface is visible. We can see there is a triangular surface that is built because of three vertices. Now we have vertex shader and fragment shader. So three vertices are fed into vertex shader. So vertex shader get executed per vertex. So for each vertex, vertex shader is executed. And when a primitive is completed, so this is here, the primitive is a kind of GL triangles. Okay, so we can think it as a primitive is GL triangle. Okay, so primitive is GL triangles. Okay, so name of the primitive is GL triangles. So this is primitive name. Okay, so this is GL triangle and it has three vertices. All three vertices are fed into vertex shader, each vertex one time till it completes the primitive. So one primitive is completed, transformed surface interpolated. So transformed now because of the vertex shader where we apply different matrices like model view and projection matrices, and then we transform the vertices. One vertices get transformed, then the surface what we see, the surface has a set of pixels. So when we have three vertices, when it get transformed based upon the primitive, we come to a surface that is transformed surface. If it is a surface, then there are set of pixels. Now this set of pixels, so those pixels, interpolated pixels, mean in the sense that a kind of the new position of the pixel and then new normal. So normal also get transformed. So the whatever the interpolation happens for the pixel positions, so those transformed surface interpolated pixel, they are fed into fragment shader, and fragment shader generates colored pixel. So pixels are getting colored. Now the colored pixel, it is called colored pixel, or we can kind of call colored fragments. So when pixel is not a part of frame buffer, color frame buffer, till then it is a fragment. So this is the name kind of suggested. So okay, so if this is a pix, okay, so rather we can say kind of we can say like it's a fragment. Okay, so pixel of fragment, and it is a fragment because it is okay, colored pixel of fragment. Then it passes through various tests like face cull test and depth test, stencil test, and so many, and it becomes candidate of the frame before it passes the test. So if it passes the test, then the fragment actually it becomes pixel. So it became color frame buffer pixel. Otherwise, before that it is not a pixel, it is a fragment. I mean, these are the terminology that is in fashion. Okay, so now we understood that if we kind of combine the vertices, then it forms a surface, and then surface, since vertex get transformed, so surface get transformed, and then whatever the new interpolated pixel locations, and I mean I can specify texel also, and the new interpolated normal that is spread into fragment shader, it become colored pixel or fragment. It passes variable test, and if it passes through, that become pixel, otherwise it is called fragment, and it become member of the color framework. So this is the OpenGL pipelining. OpenGL pipelining is big thing, and there are many things may happen in texture wise also, like creation of the texture object and texture unit and so many things. So this is part of it, and the biggest part is, so before it is fed, so this is CPU code. So like here we can say C or Python code, and then it is fed into vertex. So this is shader programming, that is C code, and once it comes out the colored pixel, then it becomes part of the C or Python code, and it becomes C and Python code. So output, this area is Python code, and this area is shader code, and this area is Python code again. So input before it is fed into the shader, and then output whatever we receive. Then so it depends upon how we have set up the test environment through which it would pass. Okay, now polygon face we have seen. So if there are 3 vertices, there can be 4 vertices, 5 vertices, depend upon what kind of primitive I have taken. So right now we have taken GL triangles primitive. So if GL triangle primitive is there, then if there are 3 vertices, then we have front face that anyway we are seeing, and there is a back face that we can imagine. So if there is a surface, then there has to be 2 faces. One is front face and one is back face. Like we have a kind of model. So if I have a model is built because we have so many triangles. We can see there are so many triangles. So triangles are they are aggregated and it forms a shape model. Now each triangle has front face and back face. So altogether we can say that this model has front and back face. So this is front, the outside of the glass or cup, and inside it is what we see more clearly. So this is the back face that is inside it, and whatever we see that is outside, that is the front face. Okay, so front face of the glass, and inside what we see the surface is. So that is back face. So okay, so inside the curve, if I have a surface, then front face and back face, like that. If there is a surface, because of the triangles are combined together, then back side of the triangle is also there. Okay, so polygon faces. Okay, so what is polygon face? So we saw it is a polygon is generally generated by the set of vertices, and it has two faces since it is a two-dimensional item. So any two-dimensional item has two faces, front and back. Okay, so how we decide that something is a front face and something is back face? So when we declare like GL triangle primitive, when we say mine is a GL triangle primitive, and we put a vertices, like if I am saying that my vertices is V1, V2, V3. So it difference means I can specify vertices in clock direction. I can specify vertices in, so if I declare that my polygon is GL triangles, then I have to specify the vertices also. So if I specify vertices in counterclockwise, then whatever the face is generated, that is considered as front face. And whatever the face is generated because of the clockwise, so if I am thinking this V1, V2, V3, so V1, V2, V3, if we specify, then it is a counterclockwise the way we are specifying the vertices. If we are specifying the vertices in counterclockwise, the face what we are seeing, so that face is front face. Okay, so if it is a counterclockwise, then the back side is automatically it is clockwise. So back face that is clockwise is the face which is clockwise, that is the back side, so that is called back face. The face which is counterclockwise, so that is called front face. So this is the way. So I have only three vertices, but depending upon the vertex, so like generally we draw the item like this. Okay, like the actual OpenGL drawing. For that we write the code like this. GL begin, and then we specify what is the a primitive name. So that is the grammar, and then we specify GL vertex, GL color, and GL normal vector. Okay, I think text coordinate. So these are the stuff generally we specify, and so if I specify the vertex like here in this example, like V2, V3 and V1, So if I specify vertex like this, then it is considered as clockwise, and whatever the surface we are seeing resultant, so that surface is considered as the normal, as considered as the front face. Okay, if it is front face, then if we specify normal, so we can specify normal, then it is front face normal. Okay, so this is the signs. So when we draw vertices in counterclockwise, then that is front face. Then by default, then other face would become the back face. Okay, so we are covering kind of what is polygon face. We will move to culling polygon face. Okay, what is culling polygon face? Culling means cutting, removing. So like we have a kind of a sphere, and a sphere is made up of set of triangles, GL triangle surfaces. So whatever we are seeing, this is front face. Okay, if I rotate this sphere or football, then again it is front face. Inside it, okay, so if I cut it, okay, so if I cut it, then inside it there is a back face, the way we shown. Okay, so inside, if we cut it, then inside, so this is back face, and if we cut it, then inside it is like a back face. Okay, so outside what we see is the front face. If we cut, then the inside cut, not the, if I rotate, all the outside around 360 degree is front face, and if we cut, then inside what the surface we see, we will see that is the back face. Means if this is a triangle, then other side of the triangle is the back face. So other side of the triangle is not the other side of the sphere. That is the inside of the sphere. Okay, so if it is made of kind of a cloth or leather, then the other side of the leather. Okay, so if my football, if I am kind of playing football, then certainly I am not going to show the inside surface, but OpenGL takes care of the drawing the inside surface also. So unnecessary computation we would kind of handle. So in that way, we can remove the mathematical computation for a particular surface. So that is the part of the discussion. So I can say enable cull face, and then I can say cull face back, because we don't need back. Okay, so only we need to draw the front face, the inside of the this football or inside of this sphere. So that we don't want to draw. If we don't want to draw explicitly, I can say that just cull the back side. I don't want the back side. Okay, so cull can be back, front. Front and back means I don't want anything. So that is front and back. Otherwise, whatever we need, we are only drawing the back side. So in that sense, we will cull front. For that, we need to enable first GL cull face. This is kind of a state management in OpenGL, and we need to enable and disable a particular feature. So we need to enable cull face first, and then we have to specify which face we want to cull. And back face means the surface that is generated when vertices are in clockwise. If it is counterclockwise, then that is front. So if I specify back, then front it would not draw, only back side it would draw. So it would save 50% of the, it would double the speed. Or if we draw front, then it would draw the front, and back it wouldn't draw. Okay, if I cull face front and back, then nothing would be drawn. Okay, so we are now in the topic reverse polygon pair. face. So we can change the grammar, internal grammar of the OpenGL. So OpenGL internal grammar is counterclockwise is the front face and clockwise is the back face. I can say GL front face is clockwise. So we reverse it. If we reverse it, then whatever we are seeing as front face becomes back and back face becomes front. Okay, so the glass front face become back, and if we cut the glass we see the inside, so that inside becomes front. If we set the orientation of the front face, the grammar of the front face as clockwise. Otherwise, by default, if front face is set for the counterclockwise vertices. So that is the science. So we saw two kind of API. One is culling the polygon face. So it consider the front face as counterclockwise or whatever is set through GL front face, and then whatever we specify back, front, so that surface it would cull. Okay, so that is the scenario. Now in lab session, we will really see what is the front and back. So I have a kind of a GL triangle and I have two light sources. One light source is red and one light source is blue. Okay, whereas the surface color is white. So when white diffuse light falls on the surface, it illuminates it as red. Okay, now so now we can, I think we will proceed. Okay, so since two lights are different, then coloring is different of the both faces. Means OpenGL after the shaders pipelining, once shader drawing is over, then OpenGL identifies the surface as front or back. Even though the pixel would be same, but it identifies front and back. So the side which is facing the light 1 is red, and side that is facing the lights 2, the back side, is blue. So same triangle, we have red and blue. Okay, so I need to enable the cull facing, and if I say please remove the back side, then this, so only red is visible and back side there is nothing. It is no color. We can say it is a black. And if we cull front side, then only blue color would appear and red color would not appear. How it works. So we will show how it works. Then we will proceed with kind of writing the actual code. So if this is a counterclockwise, then certainly there is a normal. If it is counterclockwise, then certainly there is a normal. First I would reflect it here. Then certainly there is a normal. Suppose I have a normal. So there are 3 vertices. And vertices are shown in V2, V3, V1. So it is counterclockwise. And then we have a normal. Now I am rotating this vertex along x-axis. So this is x-axis. Okay, so this is x-axis is in red. This is what I believe. So, okay, so if I rotate along x-axis, then slowly this surface would get rotated, and okay, so one time the surface would be something like this. So once it starts rotating, then one moment it would become like this. It will be very thin. Okay, since it is rotating along x-axis, then it will be little bigger. Then slowly it would become smaller, and we can see only one line. Okay, then it would kind of go in other direction. So okay, so normal. So when we are rotating, so normal is facing red light. So from this stage to this stage, this stage, this stage. Now normal is okay. So we are rotating. So here, okay, so normal is also getting rotated. Okay, so at this stage, normal is pointing exactly down. Okay, and then normal starts pointing towards blue light if I keep on rotating. Okay, so now the calculation generally happens in shader is the normal what we see and the light falls, the direction of the light. Okay, they must not, now it is kind of 0 degree. So it must not cross 90 degree. So up to 90 degree it would do the diffuse color. Beyond that it won't do. So if I am rotating it, one time it becomes 90 degree and there is no coloring. Anyway, we cannot see the surface. And after that normal starts pointing into blue light. The way we started red light and blue light. So if we are rotating, then after certain rotation 90 degree, then it starts pointing. It starts pointing towards blue light. So blue light is getting the normal. So if it is pointing towards blue light, then the pixel color would be blue. So we are seeing two pixel color. So when the surface is normal is facing the red light, then we are seeing the red light when we are rotating it, and when normal starts facing the blue light, then we are seeing the color blue. We can see. So we'll see the example. And if that is the scenario, then so this scenario we have not enabled the cull facing. So if I have enabled cull facing back, then if I enable cull facing back, then normal when it is facing red light, so that area is considered as front face because that is counterclockwise. So only red would appear when it goes towards blue light. Okay, then it would illuminate as blue. Okay, but since OpenGL identifies front face and back face, so when it is blue color is illuminated when it is going other side, so whatever the blue color it is facing towards the user, so that is the back side, so it won't show. So only red color it would show if I do the cull facing. On the other hand, if I do the cull facing front, okay, then red light would illuminate the front face as red, but we don't want the front face, so there would be nothing. So the front side, even though it is illuminated with red, it would not draw. So once it passes the shader's code, so it does the coloring of the pixel or fragment, but cull test it would not pass. because front side we don't want. The face that is counterclockwise, that we don't want. So in that scenario, it would not go to the color frame buffer, color buffer. So we would not see. So there are two parts. So in the first part, we see only the red color and we keep rotating. There is no color. But in second part, when we say cull face front, then front side, so this side would not appear at all, and only back side would appear. When normal goes that side, it rotates, and that we see blue because back side is enabled. Okay, so this is what the example will show. Whatever behavior we are seeing, that behavior we can just turn upside down if I set GL front face as clockwise. In that way, if I cull the back face, okay, even though it is in front of red light, okay, so we will see only the blue. Okay, so and if I do cull facing of the front, then even if we are the front of blue light, we'll see the red. Okay, I mean it looks a little kind of clumsy. Okay, convoluted. Okay, we'll see in the example. Okay, so what we did, we turn around the vertices. So now if vertex is clockwise, that is considered as front. If clockwise is considered front, whatever we see at the back side, that became the front. So if I say cull back, okay, whatever earlier it was front, that is gone, and whatever the back, okay, so that became front. So if I say cull face back, the front side is gone, means earlier whatever the front side is gone, so only back side, earlier back side will be shown. So this is how it would be. So probably we'll see in the example, and then it would be kind of more clear. We can start.